All
Are you
right.
are you referring to what was assigned last night or what we got today?
Not the stuff from last night. Anything before that. Because the stuff from last night is what I'm gonna like go over today in class with. Yeah. But anything from before, anything that doesn't make sense, any questions? I am up to date with the postings. All right. So all the videos have been posted. I've made announcements about them. You guys can check out. All right. I believe like everything should go back to the way it was with tutoring starting Sunday, so no nothing surprising there. Remember that my schedule changed. I will not be there on Sunday. Now I'm Monday and Wednesdays in person. All right. Also, if I'm not mistaken, this Wednesday coming is pantry. So if you guys, didn't get a chance to, sign up and go. All right. All right. If there's no more further questions, let's look at what we're getting into today. And by the way, thank you all for checking your messages and coming today. I know it was a little bit short notice. All right. So a little bit of a blast from the past. I want to simplify this expression. Who remembers how to do this?
Don't you just subtract the denominator from the numerator?
Yes, exactly, right? So we go, this is going to be what? X is top minus bottom. So 9 minus 4, which gives me x to the fifth power. And that's it. Any questions on this? Anybody? Nothing new. Just a nice old concept. All right. Well, oh, also, in case you guys are wondering, like this topic right here is on the formula sheet. Like this one right here when you divide exponents. So you don't need to memorize it. It's there. So same question. Walk me through this. How do I do this? I want to simplify y to the third over y to the 11th. How do I do this? It's okay. You can unmute yourself and say it. No problem. Anybody?
Could it be y to the eighth? I don't know.
Yeah. Yeah. It's close. So it's gonna be
Yeah.
y.
Oh, sorry.
Go ahead.
No, I finally was able to get. It's kind of like how I believe he just previously explained it, but you
Uh-huh.
can't have a negative because
Exactly.
okay, so it has to be before the uh y. I'm sorry. Okay, it's negative
Uh,
y8.
so it's y to the negative 8 power. So what
Yeah,
what can I do to fix
over
this?
Sorry, you have to put it make it into a fraction form.
Uh-huh.
And the way that you're able to do that is through putting the y on the top.
Not on the top.
Oh, well, I'm sorry. It's the one on the top. I'm sorry, and the
Very
y
good.
on the bottom is what I meant. Sorry.
Good. and then with a positive exponent, right?
Yeah, because it
So
has to stay a remain a fraction.
very good. Very good. So that's it, right? Same idea. You're
So
going to do top minus bottom, right? We're going to get a negative exponent, however, right? Because 3 minus 11, -8. But we're not allowed to have negative exponents. So we have to throw it into our denominator and write it as a positive exponent, right? Any questions on this? Anybody? Okay. There's no questions on this. Let's do another one that's familiar. By the way, tonight's homework is real simple, not too many questions. You should be able to knock it out, without like interfering with your studies for exam two. All right, so here's my third example, right? So I have n squared raised to the sixth power. So I'm trying to raise a power to a power. Help me out. What do I do here to the exponents? Say again, I'm sorry.
you're gonna. Oh, I'm sorry. I guess you're gonna multiply them. So
Right,
it will be n to the power of 12.
exactly, right? So n to the 2 times 6 power, which gives me n to the 12th power, right? Very good. So whenever we raise a power to a power, we multiply. All right. Any questions on this, anybody? Any questions? All right, there's no questions. Let's jump into what we're getting into today. All right. This is going to be a really, really cool concept, but it's not going to take that long to understand. All right. Again, homework is really, really simple tonight. Won't take you that long. All right. I mean, it's not as simple as yesterday's homework. Yesterday's homework was the bomb, right? But it's still a simple, simple question. So here's what we're getting into. We want to use the product property to simplify radical expressions. So we will simplify radical expressions in a way similar to how we simplified fractions. A fraction is simplified if there are no common factors in the numerator and denominator. So to simplify a fraction, we look for any common factors in the numerator and the denominator. A radical expression, which is like the nth root of a, is considered simplified if it has no factors of m to the n power. So to simplify a radical expression, we look for any factors in the radicand, right, that are powers of the index, right? So let me say that again. We look for any factors in the radicand, that's like the A right here, right? That are powers, right, of the index. That's the n right here for the nth root, right? So simplified radical expressions for real numbers a and m and n greater than or equal to 2, of course, right? You have the nth root, right, of a is considered simplified if a has no factors of m to the n power, right? For example, let's say I have the square root of 5, right? That is considered simplified because there's no perfect square factors in 5. But the square root of 12 is not simplified because 12 has a perfect square factor of 4, right? I could break down square root of 12 into square root 4 times square root 3, right? And then you can go a step further. Square root of 4 is 2, so the answer would be 2 square root 3. Similarly, the cube root of 4 is simplified because there's no perfect cube factors in 4. But the cube root of 24 is not simplified because 24 has a perfect cube factor of 8 inside of it, right? So to simplify radical expressions, we will also use some properties of roots. The properties we will use to simplify radical expressions are similar to the properties of exponents. We know that a times b to the n power is equal to a to the n times b to the n. The corresponding product property of roots says that the nth root of a to the b power, excuse me, the nth root of a times b is equal to the nth root of a times the nth root of b, right? That's our special property right there. All right, that's what we wanna write down and get to know. All right. Just to make me feel good, here's a definition again. Y'all know I like to repeat, right? So the product property of the nth roots, right? If the nth root of a and the nth root of b are real numbers and n is greater than or equal to 2 is an integer, then the nth root of a times b is equal to the nth root of a times the nth root of b, and vice versa. The nth root of a times the nth root of b is equal to the nth root of a times b. All right? That's our specialty right there. So here's our first example. All right. A little bit difficult, but we'll get through it. All right. So here's what the question is asking, right? They're asking us to simplify the square root of 98, right? Simplify the square root of 98. Now, square root 98, right? Now, I don't know what the answer is here, right? The best way to do this, right, is I would actually go through the perfect squares, right? And I'm going through the perfect squares because the index here is 2. Even though I didn't write the 2 there, there's an imaginary 2 there. Anytime you see a square root with no number there, just imagine that there's a 2 there, right? This is square root. Anyway, right, I would go through the perfect square indexes, right? And I would try to find one that divides into 98 evenly, right? So let's go through them, right? So we have 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, right? 9 times 9, 81. 10 times 10, 100. Now I'm going to stop at 100. I could have kept going, but I'm going to stop at 100. And the reason why is because 100 is smaller, excuse me, is larger, excuse me, than 98, right? 100 is larger than 98. So I know that whatever number I'm looking to divide into 98 is going to be smaller than 100. So I'm not even going to test 100. I'm starting off right here, right? So 81, you remember that's 9 times 9. Does 81 divide into 98 evenly? And when I say evenly, I mean that it goes in and there's no remainder, right? There's just a whole number that it goes in, right? Well, the answer is no. We know that, right? 81 is going to go in one time, but then it's going to have a remainder. All right. What about 64, right? I know that 64 doesn't go in because if I double 64, that becomes what? 128, something like that. That's not 98. So I know that's not it. What about 49? All right. If I double 49, I do get 98, right? So this is going to become what? This is going to be the square root of 49 times the square root of 2, right? And then what's the square root of 49? Right? We know that 49 is what?
7 times
7
7.
times, right. So the
7.
square root of 49 is just plain old 7 and then square root 2. This is my answer to the question, right? So on the test, what am I looking for? This is test 3, not test 2. right? What am I looking for? I'm looking for this type of answer. All right. I want the whole number times the radical and whatever remains, right? Radical 2.
This will be
That's it.
on the next exam and not the third exam.
The third exam, not the next exam.
I'm sorry, I thought you
Yeah.
were saying
Yeah. For the second exam, every when we stopped at the rational equations, right? That's what we did on Tuesday, right? That's the last topic for exam 2.
rational expression and stuff.
Yeah. But this is gonna all be on exam 3. This is why I was telling you I think exam 3 is even easier, you know? I don't mean don't try. I mean try your best on all of the exams, you know, but I'm just being honest with y'all, you know? All right. Does anybody have any questions on this? Would you guys like to see one or you feel like we could move on?
We can do another one.
Do another one? All right, let's do another one. All right. This next one's a little bit harder, but I feel like we could do it. I want to simplify the square root of 48. Right? So we want to simplify the square root of 48. Give you guys a minute to try it. I'm thinking about it on my end as well. For those of you that got the TI 36X Pro, I know you guys are probably smiling right now. Those of you with other calculators, I feel your pain. Those of you without a calculator, now we on the same level. You with me? Mhm.
¿Por qué no ladras? Dime. Bueno, eso no se hace. Ve, espera. Tú no me vas a explicar que está bien. Espera. Ven. Mira lo que dice.
Can you hear me, sir?
Mm-hmm.
Oh, okay.
So let's
I
start.
just
Let's
couldn't
start
tell.
this out. So I have what? Square root 48. So what does that break up into? What's the perfect
16 and
square that
3.
goes into 48? Say it again.
16 times 3.
Perfect, perfect, perfect. All right, square root 16 times square root 3. And the square root of 16 is what?
4.
All right, so 4 square root 3. That's my answer, and I'm done. All right. Does anybody have any questions on that? You can just use your calculator. No. If you don't have that feature, just go through your perfect squares, right? So start off from the beginning. You have 1, 4, 9, 16, 25, 36, 49. Now you stop at 49 because 49 is bigger than 48, right? And then you just start with the next lower one, right? Let's say 36. You double 36, that's bigger than 48. That's not it. You start with 50. You double 50, that's bigger than 48. That's not it. Then you get to 16. You double it, smaller than 48. Triple it, boom, it hits 48. There you go. And that's how we do it. You good?
There we do it.
Yep. Otherwise, you have the calculator, right? So I wanna
Yeah,
I
that.
wanna do some. Go ahead.
I said, I'm so sorry. That's how I did it.
Good, good. Happy. All right. So we're gonna do some more, but before we do some more, just bear me 1 second. I want to give you guys some notes real quick. Okay. So I want to give you guys some notes real quick. All right. So here we go. So notice in the previous example that the simplified form of the square root of 98 is 7 square root 2, which is the product of an integer and a square root. We always write the integer in front of the square root. This is important now. Be careful to write your integer so that it is not confused with the index. The expression 7 square root of 2 is very different from the seventh root of 2. All right. So whenever you have a number in front, make sure you write it big, right? So that you don't confuse it with an index. That's what that's trying to say. All right. Anyway, here's the sauce. How to simplify a radical expression using the product property. Step 1, find the largest factor in the radicand, the inside of the radical, that is a perfect power of the index, right? That's whatever radical you have, square root, cube root, etc., right? Rewrite the radicand as a product of the two factors using that factor. Step 2, use the product rule to rewrite the radical as the product of the two radicals. And step 3, simplify the roots of the perfect power. And that's it. All right. Let's try this out again. All right. So here we go. We got, this is for A. I have square root of 500. All right. I'm pretty sure you guys could just tell that this is going to be square root 100 times square root 5, right? And we know that the square root of 100 is just 10 square root 5. That's not too bad, right? But what about B? For B, I have the cube root of 16, right? Now, is there a perfect cube that goes into 16, right? Turns out there is, right? So we could break this up into the cube root of 8 times the cube root of 2, right? You know that 8 is just 2 times 2 times 2, 2 to the third power. So this is just very simply 2 cube root of 2.
Okay. What is that?
Any questions so far for anybody?
You're gonna. Mira, tengo la sala.
All right. Let's look at letter C now. All right. Now C is where I personally run into problems, right? I have no idea what the answer is. All right. Just to be quite frank. But I have ways, I have things that I can do to help me figure out that answer. Right? I need some more space, so I gotta move to the side, but I'll bring it back in a second, right? So I have 243. I'm going to show you guys another way to get an answer when you have some kind of big number that you just don't know, right? And I don't know what my perfect fours are, all right? But you can use another technique where you use your prime factors to give you the answer. Check this out, check this out, check this out. So 243. I want to break this down into two numbers that multiply to give me 243. Now watch this little trick. If I take 2 and I add it to 4, I get 6. And if I take that 6 and add it to 3, I get 9, right? So we know that 2 plus 4 plus 3, that's 9, right? 9 we know is divisible by 3, right? So what does that tell me? That tells me that 243 is also divisible by 3, right? So let's see what it is. I'm gonna use the calculator because I'm not sure. So 243 divided by 3, what is that? That's 81. And as soon as I saw 81, I'm done because I already know, right? 81 is just what? That's 9 times 9, right? And then 9 is just 3 times 3. Okay. Now, here's the hard part. I want you to count how many threes we have circled here, right? I have one, two, three, four, 5 threes, right? I have 5 threes. What does that tell me? That tells me that the fourth root of 243 is equal to the fourth root of 3 to the 1, 2, 3, 4, fifth power, right? 3 to the fifth power is equal to 243. Now, watch how I break this down. I need one of the roots that I'm going to write right here, one of the roots to be divisible by the index, which is 3. So, right, if I take out 3, right, I'm sorry, why did I write the third root? I'm sorry, it's supposed to be the fourth root. Sorry about that. My mistake, right? It's supposed to be the fourth root. Sorry about that. So if I write down a 3 and a 3 here, right? My first root, I need that to be the same as the index or divisible by the index. So I can just write down 4 right here. So if I put 4 of the 3's to the left, that leaves only one of the 3's to the right. You see that? And then now, when I simplify this, right, these two will cancel out, leaving back just a big 3. And then you have the fourth root of 3 to the 1 power. This is your simplified answer. All right, questions on that, because that's a brand new method that I just showed y'all. What do you think? I like this method. When I'm most confused, this is what I go to. All right, I just count how many prime numbers I have, and I just knock them out. All right, and then I put the whole numbers on the outside, whatever's remaining underneath the root on the inside.
So you're saying that the three just comes from the subtraction that you do from the roots within the squiggly. I
Right.
can't use.
Right.
Got
So
it. All right.
I'm taking the radicand and I'm breaking it down to its basic prime factors, right?
Yeah.
And then I'm counting how many they have, and that's how I get the five here. But I need to knock out the index, So I take four of the threes to knock out the index, put that to the left, and whatever's remaining, the one extra three, I leave that under the other index, and then that's it. So this is another option you have whenever you have questions like these. All right. How do you guys feel? Did that make sense? Do you want to try another one, or do you feel like we could move on?
Another one.
Other one? All right, that sounds good. All right.
Yeah.
Oh, by the way, like this is all your homework is for tonight, by the way. Just simplifying roots like this. That's it. I remember we want the big number on the outside, and we want the remainder under the roots on the inside. So go ahead, give that a try while I look at something. All right, I was checking out Monday's topic. It looks real simple, easy, and fun. Yep. We Gucci. Okay. Let me know when you guys are ready. No pressure. Some good news. I was adding up the days that we have left in class, and it looks like we're gonna have some time to review for the final, so that's good. Even though we're not ready to talk about the final, we got another test in between that and test two, but we getting there. We getting there. All right. Feel like that's enough time. For A, what did you guys get? Anybody?
I would say 12 little house 2.
Good. 12 square root 2. That's the answer. All right. What about B? What do we get for B?
Three, little three, house, three, house. I mean, sorry, three, then little three, house, three.
Good. That's the answer. How about C? A little bit harder. A little bit harder. What do you think about C? If you're not sure, also, you can say that too, or we could work
2
it out together.
2 square root 2.
So 2 square root 2. Not quite.
Okay.
All right, let's go through this one together. All right. I think it'll be easier to do this one if we use that method that I had before. So start off, right? You have 64, right? Break it down. You see that it's 64, right? It ends in 4. So you know that this thing is divisible by 2. So this is 2 times something, right? 32. 32 is also divisible by 2, right? So that's 2 times something. What's that? Like 16. And then you already know from 16 you're Gucci, right? That's just 4 times 4. And this is 2, this is 2, this is 2, and this is 2, right? So let's count how many twos I have. 1, 2, 3, 4, 5, and 6. All right. So, right, we know that the fourth root of 64 is the same thing as the fourth root of 2 to the 6th power. All right. And then now we want to break this down, right? Remember, I need one of them to be divisible by the index. So because this is the fourth root, I'm going to bring 4 of the 2's to the left. And the remaining 2's will be in another fourth root to the right. So that's just 2 to the 2. Right? And then 4 plus 2 is 6. The fourth root and the fourth power will cancel out, leaving back big 2 with the fourth root of 2 to the second, which is 4. This is your answer. All right. Any questions on that from anybody? My opinion, that's the easier way to do it than memorizing what the perfect numbers are. So anybody, any questions, anything?
No,
All right. Well, that's actually all I have for you guys today. Before you leave, just type your name in the chat so I can count you down for attendance. I am willing to stay back and help you guys with homework if anybody wants to stay back and do homework. No problem. All right.
can I ask you a question
Yeah, yeah, yeah.
about that
Let
last
me.
one too? The last one.
Oh, yeah, 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 yeah. Go ahead. Yeah.
Can you have big two, house, root two?
Right. The fourth root of 2 to the second power you're asking about, right? Am I right or wrong?
Sorry?
Say it again. I'm sorry. I was trying to hear the question, but it wasn't coming through clearly.
I'm so sorry. I didn't hear what you said. I was asking if you could have as a final answer for the third one, two with the house sign and two inside the house.
Not just 2. It has to be to the fourth. It has to be 4 because it's 2 to the second power is the answer.
Got it.
Yeah.
All right. No problem.
All right.
Thank you.
You're welcome. You're welcome. So yeah, if you feel confident, just type your name in the chat and you could go. But like I said, I'll stay back if anybody wants to do any homework. We could knock out some stuff together, no problem. All right. I'm gonna end the recording though.